For lesson 1.2, what is slope? Our goal is to identify the slope of linear equations in the form of graphs, tables, equations, and points. The connection here is that slope is a rate of change, which is related to derivatives. So for this lesson, the main thing that we're looking at is slope. Just to define that really quickly, the rate at which the answers of a linear function are changing, either increasing or decreasing. So when we were making tables the other day, you saw some of them going up or down by 2 or 5 or various other things like that. Those numbers, the change in them, that's the slope. On a graph, you'll be able to identify it as the steepness or angle of the line, which we calculate by figuring out how far up and over you move between each point. In an equation, you can usually just directly look at whatever number is attached to x, or the parenthesis set x minus some point. It will also be written as m sometimes if it's given to you. And in a table or just a set of coordinates or points on a line or whatever, you can get to the slope by doing the slope formula, which is taking the difference or the subtraction of any two y values and dividing that by the difference between those y's corresponding x values. That means that you can't just grab random y values out of 2 points and then x values out of another 2. You have to make sure to take the x and the y from the same place. But once you have them, you can just follow our slope formula, y2 minus y1 divided by x2 minus x1. Here you'll see that also written with two little triangles next to y and x. Those triangles represent the phrase change in. So if you don't want to keep writing out change in y in your notes, you can write a little triangle with a y next to it. So let's look at some of the example problems where we'll be trying to identify the slope. Here's a couple examples of graphs where, again, if we want to find the slope of this, we want to figure out how far up and over we move between those points. Here with this one, we start at 0, 1, and we end at 3, 3. That means that we're going to be moving up 2 and over 3. Since we're going up, this is positive movement, and we're going to the right, this is also positive movement. In this situation here, we've got a couple of different points, and again, any of these should work because it's going to be the same distance between them. Between the 1, 4 and the 2, 2, we appear to be moving down 2 and over 1. Between these 2 points, we see the same thing. We end up going from 2 to 0, which is down another 2, and from 2 to 3, which is over another 1. This slope should be negative 2 over 1, and remember, anything over 1 is just itself, so we could call this negative 2. Really quick for our equation here, remember this is just the number attached to x. In this case, 5 is attached to x, and even if there was an x minus 1 parenthesis set, it would still be this one. And lastly, we've got a statement here, the line passing through the points 0, negative 6, and 3, 9, and then we also have a table. In this case, this is where we'd want to use our slope formula. When you're assigning which point is x1, y1, and x2, y2, it's generally good to make the point that's further to the right x2, y2, but it doesn't actually particularly matter. In this case, the point further to the right is 3, 9 because it has a bigger x value. So if I make that y2 and x2, my formula would look like this. M equals y2 minus y1, and we'll need to make sure to put that in parentheses because we're subtracting a negative, and that is over x2 minus x1. Minus a negative means this will add, so 9 plus 6 is 15, and 3 minus 0 is 3, and this can again simplify. 15 divided by 3 is 5. The table is going to be no different. We just pick any two of the points in the table that we want to do this. Again, you probably want to make x2 and y2 a lower point on the table, so if I choose 3, 1, I probably want to use either 2, 3 or 1, 5 for my other point. Probably be good to use 2, 3 in this case. We have m equal to 1 minus 3 over 3 minus 2. 1 minus 3 is going to be negative 2, and 3 minus 2 is going to be 1, so we are going to have a slope of negative 2 right here. Let's head over to our Desmos file to see what this would look like there. So here's some of the stuff we talked about before. The slope of a line is a ratio of the change in y values to the change in x values, just that definition again. And then down here are instructions to find the slope of a line. Input any two of the coordinates on the line or in the table into the spots below. So just like before, we could take any two of the coordinates that we saw from the graphs or from the statement with the line passing through the points, or just any points in the table here. Let's take the points from our last one, which would have been the 2, 3, and the 3, 1. And down here, here's that same slope formula with our change in y, or difference in y over difference in x. And there is the -2 that we also found for our slope like before. Awesome. Next time we will be talking about distance as a function. See you soon.